Hi all. So we were talking about momentum last, so I just want to do a quick little video about some of the key terms as you get into that second set of momentum questions, and we're going to talk about this in class as well. But just so you have this, that you can go back and watch. A couple of terms you need to know. System means a collection of objects that we're observing, a system like a star system or a planetary system. In this case, we're going to do a lot of skateboarders colliding into each other or bowling balls hitting each other in a system. It just means a collection of objects in one space. A closed system is a system in which masses do not enter or leave. So in this case, something like a bowling ball lane, right? Or planetary system, unless something can, or exit, like a comet. But ideally, a closed system is something where things happen and masses aren't entering or leaving. So you don't have like a random, bow and arrow shot into a system or something like that. So closed system, isolated system. So closed system is one thing. Isolated system is a system in which you don't have any what we call net external forces acting on the objects. So for instance, if we had an isolated system without friction, you wouldn't have friction acting on the object at any other given time. So isolated system, a little different than closed system. Closed system just means masses aren't entering or leaving. Isolated meaning that you don't have a push or pull, an external force, gravity, friction, air resistance, something like that. Then you have momentum, which we've been talking about, P equals mv. Momentum equals mass and velocity. It's a vector set because velocity is a vector. It's speed in a given direction, and you need two things to have a vector, right? So you need, in this case, speed in a given direction is velocity. We'll sometimes say like, skateboarders is riding at 6 miles an hour easterly or something. So that's velocity as well, when speed has a given direction. But it's a quantity of motion. Momentum is very important. Momentum is part of every system and every field, except for atoms. And this is why we get the quantum world, because electrons don't have momentum, and we're still working on that, and we need your help as you become scientists in the future. The change in momentum we express as delta mv, or delta p, if you will, but delta mv is typically how you'll see it. I'll draw it on the board here in class just to make sure you're aware of that. And of course, delta t is the change in time. What else? Oh, net force. So you'll see an F with a little net written beside it, and that just means net force. So those are the key terms you need to know, and we have two equations that you're going to want to know. P equals mv, so P is velocity, m is mass, and P is momentum, m is mass, and v is velocity. So P equals mv, momentum of an object. And then we have our change in momentum. And the change in momentum can be expressed as delta P or delta mv equals force, F, which is mass times acceleration, multiplied by delta T. So the change in force over a given amount of time, that's a rate. So the change in momentum is equal to the change in force in a given amount of time. Sorry about that. And the change in momentum is the product of the external force acting on the length of time. So we're going to look at a few questions today about that in the coming days, about momentum and force in a given system, whether that's isolated like two ice skaters, or whether that's in a closed system, and talk about the practical consequences of that. So if you have any questions, let me know, and otherwise, rock on, keep up the great work and work on those proficiencies.